तो अपन क्या सीख रहे थे अभी? सुपरपोजिशन, इजंट इट? वी वर लर्निंग सुपरपोजिशन. या सुपरपोजिशन ऑफ SHM and waves. ठीक है? Means we are going to do both of these topics in one go, the particular superposition case. So till now we studied how the superposition happens. Similarly, the SHM also, like the superposition of SHM also. Huh? Yeah. So basically, like we got to know, like let's suppose if there is one particle. Now, if let's suppose if one SHM started appearing from here and throws the particle by let's suppose 1 meter, and another SHM is there which throws the particle by let's suppose 2 meters. How much? 2 meters. So basically we will see if these SHMs will overlap with each other, then the particle will be exactly thrown by how much meters? 3 meters. That was yeah. Yeah, and let's suppose if one SHM brings the particle by almost equal to 4 meters, and this for the particle brings the particle by 3 meter, then we got to know that yeah, so this was almost equal to 5 meters of oscillation, isn't it? Means 5 मीटर का एम्पलीट्यूड हो गया. तो इसी चीज के ऊपर अपन अभी हम बात करने वाले हैं अच्छी तरह से. ओके, 1 मिनट, जस्ट 1 मिनट, 1 मिनट. ठीक है, 1 मिनट, जस्ट 1 मिनट. वेयर इज माय now look over here. So we are going to talk about that superposition itself, how that superposition happens and how it works. And before to discuss much more in a great sense, to discuss how it happens, we will have to consider two different kinds of SHMs or something like that. ठीक है ना? तो हमने SHM जब पढ़ा था, तो जो SHM का इक्वेशन था वो एक सिंपल इक्वेशन था, isn't it? So SHM equation was totally simple. Let's suppose if we consider two SHM, if we consider two SHMs, है ना? तो SHM इक्वेशन हम कैसे लिखते थे बेटा? मान लो कोई एक पार्टिकल SHM कर रहा है ऑन द एक्स एक्सिस, ठीक? If this particle was performing SHM on the x axis, then we used to tell if this was main point, this is plus a amplitude, this is minus a amplitude, then x was written as a sin omega t plus phi, है ना? यही था ना? हाँ, so this is the equation of SHM. So basically, I'll write that. Let's suppose if the first particle is doing in such a way that its initial phase constant is 0. So x1 will be, amplitude will be different, sin omega t. Another SHM means another SHM which is over here is a2 sin omega t plus delta. Means one of the wave is starting from midpoint, another wave is starting somewhere, another particle is starting somewhere over here, and I'm trying to superimpose these two SHMs. Are you able to get me or not? Now you know that the net x net is given as vector x1 plus vector x2, isn't it? The total superposition of SHM, vector sum of SHMs, isn't it? So that will be equal to how much? A1 sin omega t plus a2 sin omega t plus delta or not? Are you able to get me? Now, basically this is sin a plus b form, isn't it? So if I write sin a plus b form, then what it will become? X net will be equal to a1 sin omega t plus a2 sin omega t cos delta plus it will become a2 cos omega t. Are you able to get me or not? Is this clear? So basically, we'll try to get this sin omega t common. So you're left with a1 plus a2 cos delta sin omega t plus a2 sin delta cos omega t. Did you got this relation? Are you able to get me? Now we'll try to see. We will basically try to understand how is this possible, how to write these equations and all. Okay. So I'll show you one trick to do it. Basically, let's write over here x net is equal to a1 plus a2 cos delta sin omega t plus cos omega t. Is that clear? अच्छा, अब एक फॉर्म आता है, एक ट्रिग्नोमेट्री का फॉर्म है बेटा. मान लो अगर तुम्हारे पास a sin थीटा प्लस b sin थीटा दिया हुआ है ना? क्या दिया हुआ है? सॉरी, a sin थीटा प्लस b cos थीटा. सॉरी 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 सॉरी. ठीक. हाँ. यस. या. सो मतलब अगर मान लो a sin थीटा प्लस b cos थीटा एक फॉर्म है ना? तो ध्यान से देखो. बेसिकली अगर मैं इस पूरे a sin थीटा को रूट अंडर ए स्क्वायर बाई बी स्क्वायर से डिवाइड कर दिया प्लस बी कॉस थीटा को रूट अंडर ए स्क्वायर प्लस बी स्क्वायर से डिवाइड कर दिया एंड इसको मल्टीप्लाई कर दिया रूट अंडर ए स्क्वायर प्लस बी स्क्वायर. बताओ तो कोई कोई कंक्लूजन निकल रहा है क्या इससे? देखो तो जरा. कैन यू सी इट? कैन यू ट्राई टू फाइंड आउट सम कंक्लूजन आउट ऑफ इट? थिंक. That is not going to get cancelled out. Think. You see over here. Let's see. Let us see. Let's suppose if I have a triangle. Let's suppose if I have a triangle and this angle is alpha. Okay, this angle is alpha and this is a, this is b. Then this is root under a square plus b square, isn't it? So look over here. A by root under a square plus b square is what? A by root under a square plus b square, that is sine alpha or not? That is sine alpha into sine theta. That is sine alpha into 1 minute. Sorry. 1 minute. One mistake is there. Let us. This will not give the result. Let us call this as b, and this is called as a. So basically, a by root under a square plus b square will become cos alpha or not? Cos alpha into sine theta plus sine alpha into cos theta root under a square plus b square. Are you able to get me? So what is this relation? Cos alpha plus sine alpha. This is once again sine a plus b form. So sine alpha plus theta root under a square plus b square. Is that clear or not? Similarly, I'll apply this relation over here. This is of the same form. If I consider this as sine, basically if I consider this as some alpha or something like that, and then this as sine theta or something like that, then I'll get same kind of relation. Look over here how I'm comparing. So x net means what I'm doing is I'm putting this a1 plus a2 cos delta as cos phi. क्या चीज पुट कर रहा हूं? Yeah. And a2 sin delta as A2 sine alpha, sorry, delta is there now. Sine A2 sine delta as sine phi. So if I compare that with this kind of a relation, then I'll get the x net. This implies that the x net becomes what? X net will be equal to root under a1 plus a2 cos delta whole square plus a2 sine delta whole square or not. And then this will just change into sine what? Sine alpha plus theta. It will change into what? So theta is basically my omega t or not? Correct. And then what I have to consider? I have to consider alpha. But alpha is nothing but over here I'm considering it as phi or not. So sine omega t plus phi. Are you able to get me or not? But then the question arises, what is this phi value? So if I divide sine phi by cos phi, then that is equal to what? Tan phi. And tan phi is equal to how much? A2 sine delta divided by A1 plus A2 cos delta. So the basically the value of phi is over here is how much? A tan inverse. Are you able to get me? A2 sine delta by A1 plus A2 cos delta. Is that clear? So look over here. This is the whole term which I got. But this term I can still expand it and all. So I'll expand. I'll do that expansion directly. So that is a1 square plus a2 square cos square delta plus twice a1 a2 cos delta plus a2 square sin square delta. Look over here, I can take a2 square common, it will become sin square delta plus cos square delta or not? Are हाँ या ना? So that becomes what? Sin square delta plus cos square delta is 1. So what you got as a relation? That is equal to root over a1 square plus a2 square plus twice a1 a2 cos delta. Are you able to get me or not? So this is how the x net is written. The net equation means the net equation is written as root under a1 square plus a2 square plus twice a1 dot a2, because cos delta can be written as a1 dot a2 sine omega t plus tan inverse a2 sine delta divided by. So this is the whole equation of SHM after superposition. After superposition. Are you able to get me or not? So basically you can see that what is the meaning of that? You can see that this is nothing but a net or not. And this is nothing but the final phase difference or not. Yes. So x net is also equal to a net into sine omega t plus final phase difference. So what is the meaning of that? That when two SHMs are superimposing on each other, then the resultant the resultant thing which we are getting is also a SHM equation or not? Yes. So that's the meaning of that. That when you superimpose two SHMs, you are going to also get a two SHM on it. It's not possible that you will get some kind of another thing. It's not you will get that some kind of a displacement. You are going to get two SHM itself. क्या मिलने वाला है तुम्हें? 2s means out of combined two SHMs, you will get one final SHM. Is that clear or not? तो मतलब इसका मतलब क्या हुआ कि जैसे मान लो अगर इस पार्टिकल के ऊपर एक एसएचएम 4 मीटर ऊपर क्यों लेके जा रहा और दूसरा एसएचएम 3 मीटर इधर क्यों लेकर जा रहा, तो जो पार्टिकल है ना बेटा वो ऑसिलेट कर रही है कुछ इस तरह से, है ना। उसकी जो एसएचएम की जो लाइन है वो 5 मीटर्स पे है, ये हो गया उसका मेन पॉइंट, ये होगा उसका एम्पलीट्यूड 5 मीटर और इधर क्या होगा बेटा -5 मीटर। इज दैट क्लियर और नॉट? आर यू एबल टू गेट मी? So this is called as superposition. Now you look over there at NIT. When you are calculating NIT, you got NIT as net amplitude as root under A1 square plus A2 square plus twice A1 A2 twice A1 dot A2 है कि नहीं? यही है ना? That is absorbed by the dot product or not? So what does this dot product is representing? Basically this is just like a vector equation or not, where I need to place one of the vectors at the base. This is like parallelogram law of vector addition. One of the amplitude is at the base, another amplitude is inclined over here. Then the resultant amplitude can be calculated using parallelogram law, isn't it? So the resultant amplitude will follow this path, where the question arises that which amplitude you are going to put on the base. So whichever the smaller amplitude will be there, the smallest amplitude will be kept at the base. Let's suppose I have A1 right now, and then the A2 will be over here, making the initial, look over there, when I was considering A1 and A2, see that there is an initial gap between A1 and A2 or not. So this angle is basically equal to delta. क्या इसके बराबर है ये? Delta. So A1 dot A2 is A1 A2 cos delta. Are you able to get me or not? मेरी बातें समझ में आ रही हैं? And this resultant angle is making some angle with the initial amplitude, and basically that's what you have calculated. This is basically phi, and that phi which you have written over here as tan inverse A2 sin delta A2 cos delta. Are you able to get me or not? Is this clear? Did you understood the idea? So this is what is the condition. This is what is the meaning of superposition of two SHMs. That they will provide us the resultant amplitude. What they are going to provide us? Yeah. So the how basically the question arises that how you are going to do all this superposition. So you have to consider some of the factors. That first thing is that you have to convert all the trigonometric ratios. Like the SHM equations can be anything, na? It can be even cos, it can be also sec or cosec or something like that, isn't it? So you have to convert all the trigonometric ratios. The first rule is to find the superposition in a correct way, convert all the trigonometric ratios in terms of sine. In terms of क्या चीज के रिस्पेक्ट में कन्वर्ट करना है बेटा? Sine. Yeah, and इसके साथ एक और कंडीशन है, and ensure that ओमेगा टी टर्म इज पॉजिटिव. क्या मानना है ओमेगा टी टर्म को? ये जो ओमेगा टी यहाँ पे लिखा जा रहा है वो कैसा रहना चाहिए? पॉजिटिव. इज दैट क्लियर और नॉट? ठीक. सेकेंड पॉइंट क्या बोला कि अगर हम वेक्टर रिजल्ट कंसिडर कर रहे हैं तो A1 is that amplitude, A1 is that base amplitude which is smallest. कैसा रहना चाहिए? Yeah, means the smallest amplitude will be only considered for the base amplitude. Are you able to get me or not? Is this clear till now? Now, next thing is last important thing. Try to consider even positive sign between omega t and delta. Look over there. When we are considering omega t and delta, there is a positive sign. These equations are solved for the which case? Positive sign. So that is why you need to consider the particular omega t in terms of delta. Are you able to get me or not? Yes. So should we solve some questions regarding that? Okay. So the first question is, let's suppose at a point P, two SHMs are superimposing. One SHM is given as x1 is equal to 3 sine omega t, and another SHM is 4 cos omega t. Then find the resultant SHM equation. Then find the resultant SHM equation. Do it fast. बताओ जल्दी से क्या होगा? बताओ क्या होगा? Mm-hmm. Tell me what is the answer? No, no, no. You'll get something else. Check it. Apply the rules. You look over here. See, x1 is 3 sine omega t, है ना? But x2 is cos. So x2 I have to convert it in sine or not? So cos can be written as sine omega t plus pi by 2, है ना? That is cos omega t only, isn't it? So basically, how to write that? Now look over here. So initial delta you got. Delta is how much? Pi by 2. A1 is 3. A2 is 4, isn't it? So x net will be what? Root under. It will be how much? 3 square plus 4 square plus twice 3 into 4 cos pi by 2. Yeah, yeah. And into sine of something that all those terms, isn't it? So basically, if I put sine omega t plus that will be tan inverse. I'll write it over here. I'll write directly as 5 first of all. I'll directly calculate 5 over here. 5 will be tan inverse. A2 is 4. sine delta, which is sine 90, isn't it? Divided by a1 is 3 plus 4 cos 90. Cos 90 is how much? 0. So this becomes 0. Sin 90 is 1. So this is phi is equal to tan inverse 4 by 3 or not. But tan theta 4 by 3, that is happens for 53 degree, isn't it? So phi is equal to 53. And this one is how much? This one is also 0. So this is 4 square plus 3 square, which is 25. So x net is equal to 5 sine omega t plus 53 degree. That's your answer. Got it? You want to solve one more question? Okay. Write it fast. Hmm. 1 minute. Yeah. Okay. So can I move ahead? Write one more question. If x1 is equal to 1 minute, x1 is equal to, this one is a very good question. 5 sine omega t plus pi by 6 and x2 is equal to 10 cos omega t. Equation of resultant equation of SHM. Find the resultant equation of SHM. Hmm. Tell me. Think. This is an easy question. You have to think. Just one thinking and this question is solved. Acha, 1 minute. If I want to write, the equations will be written as x1 is equal to 5 sine omega t plus pi by 6. x2 will be 10 sine plus pi by 2. यही होगा ना? Now here are two different initial phase differences or not? Yeah. So delta phase difference will be how much? Pi by, which one is, that will be pi by 2 minus pi by 6, isn't it? Okay. So that means what? How much is this value? 6. So can you solve it? Pi by 3. कितना आया delta? So the question arises, look over there. When you are writing delta, you are writing pi by 2 as first or not? So you see that the formula is what? That is A2 sine. So basically, which one will be A1? A1 is the smallest amplitude. So 5 is my smallest. Yeah. So x net will be how much? Root under 5 square plus 10 square plus twice 5 into 6 into cos 5 into 10, yeah, into cos pi by 3 into sine omega t plus tan inverse a2 sine, how much is that? A2 sine delta. So tan 10 sine pi by 3 by 5 plus 10 cos pi by 3. If you solve it, you'll get this relation of x net or not. That's my equation of SHM or not. Are you able to get me? So that's my resultant equation of SHM. So now you got the idea how to superimpose on all for the SHMs or not. You got the idea or not? ठीक है? अब ध्यान से देखो, अब जो चीज हम समझने जा रहे हैं, basically this was called as superposition of SHMs. We had two SHMs, but we know that when we consider the waves, what we consider, there are not only two SHMs but infinite SHMs or not. So that's the biggest question where we will have to think, where we'll have to understand that how the SHMs happens, how the superposition happens. ठीक है? तो बेसिकली मान लो एक पार्टिकल है, मतलब ऐसे हजारों पार्टिकल अरेंज थे, उसमें से कोई एक पार्टिकल, ठीक, and there are two sources which are, there can be any kind of source like sound source, light source, whichever source, and these two sources are sending some waves on this particle, means sending some SHMs on these particles. So these SHMs will combine once again, yes, and they will try to provide the resultant SHM or not. That this understanding of resultant SHMs are called as interference. क्या बोलते हैं इसे बेटा? Why it is called as interference? There is a reason for that. That you will see that. Let's suppose when I have two waves, one going like this way, another going like this way, and they appear on the particle P, you will see that these SHMs मिलके क्या कर रहे हैं? ये दोनों मिलके फॉर्म कर रहे हैं, है ना? यही पॉइंट है। और कुछ तो बोलो, हाँ है ना? यस। अच्छा, what we will observe that, let's suppose this time if the SHM is of such a form that this one is going forward and this one is downward and going towards the particle, then when they will appear on the particle, what you will see that there is an envelope which is, the particle is not going to displace. So the resultant SHM is nothing, isn't it? This is here nothing, no SHMs. Here there is maximum SHM or not. So this process of creation of a maximum SHM and a minimum SHM is called as interference. क्या बोलते हैं इसे बेटा? इंटरफेरेंस, है ना? जैसे मान लो नदी है, नदी, उस दिन हम लोगों ने एग्जांपल लिया था ना, रिपल्स जो क्रिएट होते हैं, तो कुछ रिपल्स मिलके एक बड़ा सा रिपल बना देते हैं और कुछ रिपल्स एक दूसरे को डिस्ट्रॉय कर देते हैं। तो दिस कॉम्बिनेशंस ऑफ क्रिएशन ऑफ basically maximum ripples, maximum length in the ripples and the minimum length in the ripples is called as SHM. Just not only maximum, it's a combination of maximum and minimum. Means if there is a maximum, then there will be a minimum also. Is that clear or not? Are you able to get me? So let's suppose if source S1 is sending some waves, then it will have some wave equation on the particle. Let's suppose if this source is from source S1, the distance is x1. How much is the distance of the particle? And from S2, the distance is how much? X2. The wave reaches at the same time t and t. Are you able to get me or not? So then, 1 minute, you have called me. Then the equation, the first source equation will be what? Y1 will be equal to, the amplitude can be different, A1 sine omega 1t plus k2 x1 or not, k1 x1, sorry, क्या लिख रहा हूँ मैं, the wave number 1, isn't it? अच्छा, y2 will be how much? a2 sine omega 2t plus k2 x2, यही होगा ना रिलेशन, and then they will merge together. So y net will be written as y1 plus y2 and so on, है कि नहीं? लेकिन अब एक बात आती है बेटा, ट्राई टू अंडरस्टैंड, सोचना जरा कि लेट सपोज, अच्छा, कैन यू टेल मी व्हाट इज द मीनिंग ऑफ द वर्ड फ्रीक्वेंसी? फ्रीक्वेंसी मींस नंबर ऑफ ऑसिलेशंस पर सेकंड, है कि नहीं? Now, let us think of one case. A wave is there which is oscillating 5 times in 1 second. And another wave is there which is oscillating 10 times in 1 second. And if I superimpose them, what I do? Superimpose. Is they are going to superimpose on each other or not? The answer is no. The answer is no. Try to understand what is the meaning of superposition. What is the meaning of oscillation? Basically, let's suppose if I have a oscillation of 1 second, and if this wave oscillates how many times? 5 times. So the graph will be what? 1, 2, 3, 4 and 5, ऐसा कुछ ग्राफ होगा, है ना? अच्छा, अगर 10 टाइम्स है तो ये ग्राफ और छोटा हो जाएगा या नहीं छोटा हो जाएगा, है ना? तो एक बात बताओ, इन दोनों की जब फ्रीक्वेंसी अलग अलग है, इफ दे हैव द डिफरेंट फ्रीक्वेंसी and if I am trying to superimpose, is it possible that any kind of overlapping of the regions can happen? No, na. Is this overlapping can happen? The answer is no. So this is what is the condition. Like let's suppose if we are considering two kinds of sinusoidal waves, then they will not superimpose if their frequencies are different. They will not superimpose if their frequencies are what? Different. So from here the concept came, and that concept is called as the first limitation which we put on the interference, and that is the condition of sources itself. So we have two kinds of sources. One is called as coherent source. Another one is called as incoherent source. Is that clear? How many kinds of sources are there? Two. One is called as coherent. Another one is called as incoherent. So then, if I have coherent source, that means the source is a single frequency wave generator. So look over here. If these particular waves have the same frequency, then they are going to be called as which kind of source? Coherent source. क्या कहेंगे उसको? And the coherent source creates which kind of waves? These sources generates coherent waves. Coherent waves. Are you able to get me or not? ठीक. दूसरी पॉइंट इनकोहेरेंट सोर्सेस क्या है? द सोर्सेस विथ वेरिएबल फ्रीक्वेंसी. The sources with variable frequency generator, wave generator, are called as which kind of sources? Incoherent sources. Are you able to get me or not? And for the incoherent source, the source will generate wave. किस तरह की waves? Incoherent waves. Are you able to get me or not? Now look over here. The condition of interference, basically if I want these waves to be superimposed and generate this maximum and minimum intensities or waves, they are called as basically what? Interference. इस phenomena को क्या बोलते हैं बेटा? What is interference? Is the phenomena in which there is a generation of maximum intensity and minimum intensity of wave. Right now I told you now. See that the particle goes, if I have these two sources, and if these two sources are merged in such a way that the particle is displaced maximally and the particle is not even displaced. So maximum displacement is what? Maximum intensity. And zero displacement means what? Minimum intensity. Yes. So basically this phenomena of generation of maximum and minimum intensity is called as interference. क्या बोलते हैं इसे अपन? मेरी बात समझ में आई या नहीं आई? तो इसका पॉइंट क्या कहने का मतलब ये है कि अगर तुम्हें इंटरफेरेंस चाहिए, इफ यू वांट सम एनी काइंड ऑफ इंटरफेरेंस, then there are some necessary conditions. The first condition is the sources should be always coherent in nature. Should be always कोहेरेंट. अगर कोहेरेंट है मतलब सिंगल फ्रीक्वेंसी, दोनों सोर्सेस कैसे रहने चाहिए बेटा? सिंगल फ्रीक्वेंसी के, उनकी फ्रीक्वेंसी क्या होनी चाहिए? मैच. सिंगल फ्रीक्वेंसी वाले इस तरह के वेव्स को हम बोलते हैं मोनोक्रोमेटिक वेव्स. क्या बोलते हैं उसे अपन? So coherent sources also generate which kind of waves? Monochromatic waves. And only the interference can be only brought out of which kind of waves? Beta, monochromatic waves. Are you able to get me or not? Second point. अब देख, अब हमारे पास दो सोर्सेस हैं. अब हमने सोचा एक एक्सपेरिमेंट करते हैं कि मान लेते हैं ये भी एक कोहेरेंट सोर्स है, ये भी एक कोहेरेंट सोर्स है. दोनों के पास सेम फ्रीक्वेंसी है, लेकिन सोर्सेस जो हैं अलग अलग चीजों से प्रोड्यूस हो रही है. मतलब ये वेव्स आर नॉट प्रोड्यूसिंग फ्रॉम द सेम सोर्स. इज दैट क्लियर? So remember that whenever you consider any kind of an independent source, any independent source is never coherent. Why? Due to manufacturing limitations. ऐसा कभी भी जिंदगी में पॉसिबल नहीं है कि तुम दो सोर्सेस लो और उन दोनों सोर्सेस को इंडिपेंडेंट रखो, भले कितना भी ट्यून कर लो, सेम फ्रीक्वेंसी ऑफ वेव कभी भी जनरेट नहीं करेंगे. इज दैट क्लियर और नॉट? ठीक है. तो हाउ डू वी जनरेट द कोहेरेंट सोर्सेस? देन वी डू, सो ऑल कोहेरेंट सोर्सेस are generated by splitting of waveform of single source or that are the single main source of energy. क्या करेंगे हम बेटा? हम सोर्स एक ही रखेंगे. सोर्स क्या सा रखेंगे? एक ही रखेंगे. एंड देन वी विल जस्ट डिवाइड इट एंड देन वी विल टेल इट दैट दीज आर आवर टू डिफरेंट सोर्सेस बट दे आर एक्चुअली मेड. मतलब हम क्या करेंगे, जैसे एक एग्जांपल बताता हूँ. जैसे यंग्स ने क्या किया कि उसने एक सोडियम लैंप लिया. क्या लिया बेटा? ठीक. और उसके सामने उसने एक दीवार लगा दी. मीन्स ही जस्ट पुटेड वन कार्डबोर्ड from which the light was passing through one of the gate. Okay, this is one of the gate. And then in the next gate he just instead of making one hole, he made how many holes? Two holes. How many holes he made? Two. So look over there. If these are two different holes, basically whatever the light that will appear from that sodium lamp, ठीक है, will pass through this first hole first of all, isn't it? And then this hole will once again go through these holes. If it passes through these holes, it will be divided into two different waves or not. Are you able to get me? Which are, that means these sources, these particular points can behave like a two different S1 and S2 sources, but they are originally originated from what? A single source. Are you able to get me or not? So if a source is basically, you can only get the interference out of this method only. And if this method is followed, that means basically we are following coherent sources, and coherent sources means monochromatic. That means omega 1 must be equal to omega 2 and k1 must be equal to k2. Are you able to get me or not? Okay, so that means what? When we are considering two different waves, so y1 must be equal to a1 sine omega t minus kx1, and y2 will be a2 sine omega t minus kx2. Is that clear? मेरी बात समझ में आ रही या नहीं आ रही? Write this first, then I'll move ahead. Okay. Sorry. So look over here. If I just find out y net will be equal to a1 sine omega t minus kx1 plus a2 sine omega t minus kx2. Now once again you see that these are our two waves, isn't it? They are superimposed on each other having two different amplitudes. And I have the form of sine omega t minus kx1 and all or not. Okay. So look over here. Then once again, what you are going to get? Oh, sorry. Yeah. Then once again, what you are going to get is the net path difference between the waves. But here the net path difference will this time change, isn't it? Here I have two different initial phase differences or not. So that will be equal to phi 2 minus phi 1, which is written as omega t cancel, and that can be written as kx2 minus x1. Can I write like this way or not? And that is what is called as phase difference between the two waves. क्या बोलेंगे इसको? We can see that, let's suppose if this is point P, if one wave is appearing in such a way, like this way, and another wave is coming like this way. So see that you have a net phase difference of some angles over here or not. So this is called as phase difference. क्या बोलते हैं इसे अपन? Phase difference, and that is exactly equal to kx2 minus x1, while x2 minus x1 is called as path difference. So delta x is equal to k, which is 2 pi by lambda into delta x. Delta x is called as beta what? Path difference between the waves, and this will actually tell you that whether the waves after superimposing on each other will be able to superimpose perfectly in such a way that the intensity can be maximum or minimum or not. What? That is what I'm going to do right now. That is what we are going to tell. How it is going to do, that we need to understand. Yes. There is some specific value for delta x and all. Okay. So now look over here. When you did that SHM, we got to know that they can superimpose in a easy way, and the net was provided by this equation. So this is also like a SHM equation or not? Sinusoidal equation, isn't it? Now once again, when you will do all those calculations, or once again you expand it and you read it, you will end up with the resultant amplitude as root under a1 square plus a2 square plus twice a1 a2 cos delta phi, because delta phi is my initial phase difference between the object or not. Yes, just like we did this question. We did this question now. Here there was one term, here there was one term. So that is delta phi. This delta is working like a delta phi over here. Are you able to get me? So there will be there. So but yeah, they are going to be there. But that's what we are ignoring right now. Why we are ignoring it right now? Because when you are going to write that equation, when you are going to write that sine equation, it's of no use. Basically, we know that whatever wave which will appear over here is definitely going to create a SHM over here, isn't it? So what we want in the SHM, we want the net amplitude of the SHM, isn't it only? So that is why we are ignoring this relation of sine omega t kx1 and other things. Okay, because I know that if the two waves are sinusoidal, it will be also sinusoidal. Are you able to get me or not? If look over there, these waves are sinusoidal or not, sine waves or not. So that is why the resultant will be also sinusoidal. So that's why we are ignoring it. Okay, मेरी बातें समझ में आई? So basically you got the relation of net square is equal to a1 square plus a2 square plus twice. Today I will do the formula thing. Tomorrow I'll make you understand practically how that happens. Okay. Tomorrow I think I'll not be able to take class. Day after tomorrow only I'll be able to take. Okay. तो वेंसडे वेंसडे तुम क्यों वेंसडे क्या है तुम्हारा हॉलीडे है क्या? अच्छा वेंसडे तुम्हारी क्लासेस रहेंगी या नहीं रहेंगी? अच्छा वेंसडे रहेंगी तो ठीक है, तो कल ही ले लूंगा मैं क्लास, वेंसडे को नहीं लूंगा. ओके. Oh, that I forgot. Shit, worst day. Ah. Now look over here. Now let us come to one of the biggest important thing. When we are talking about amplitude, and then when I was telling about the intensity, you see that when I was calculating intensity, here there are 3 to 4 terms. First one is velocity of wave, frequency of wave, density of the string, and then there was one term, amplitude. Now you look over here. Here omega is always constant. We know that for coherent source. Velocity of wave is also constant for coherent source. Density will be also constant. What is variable? Amplitude is different or not for different SSMs. So intensity is directly proportional to amplitude square, isn't it? Yes. So that's what we will see, that we know that as intensity is directly proportional to amplitude square. So I can write intensity of the wave directly over here. That net intensity which will be distributed or which will be transferred to the particle P will be equal to I1 plus I2 plus 2 root under I1 root under I2 cos delta phi. Is that clear or not? And this is the equation of intensity which the particle receives after two waves superimpose on it. Is that clear or not? Hai ki nahi? Are you able to get me? Now, let us just try to see the condition of maximum and minimum intensities. अब ये इंटेंसिटी देखो, ध्यान से देखो, यहाँ पे तो वेरिएबल है ना, थोड़ी ना कांस्टेंट है ना. कैसी ये इंटेंसिटी? वेरिएबल है ना. लुक ओवर हियर, as it is a variable intensity or not, and it depends upon delta phi also to provide us whether it will be maximum or minimum or not. So I want to know whether this intensity which the particle receives, at what conditions it will be maximum. and at what conditions it will be minimum. Basically try to understand I max, the conditions where the maximum intensities are, where if we find, means the conditions when the maximum intensities are calculated. Basically, those kind of conditions are called as constructive interference. क्या बोलते हैं उसे अपन? And the intensities where the point where I'm getting minimum intensities are basically called as the point of destructive interference. Are you able to get me? How many kinds of interference are there? Either maxima or minima. In mediator is never ever there, isn't it? So either it will be maximum or either it will be minimum. Mediator is not there. So maximum is called as maximum interference or constructive. Minimum is called as minimum interference or destructive. Are you able to get me or not? So the question arises that how to get the maximum value when this I will be maximum. I1 and I2 will never ever change because A1 and A2 are never ever changing. Are you changing the source? No. So A1 and A2 will never ever change. And I1 and A2 similarly will not change. So what can change? This delta phi can change. Na? I can make the source little bit farther, one source farther, one source nearer. And I can change the path difference or not. Yes. So let's suppose if I have a constructive interference, then we know that we can change cos delta phi. So to get the maximum value, you know that cos values, any cos theta has two values. It has a maximum value of 1 and minimum value of -1, isn't it? So if I can put cos delta phi as 1, I'll get the maximum interference or not. So cos delta phi will be maximum when delta phi, अरे cos की वैल्यू मतलब कब 1 होती है, 0 पे होती है, फिर कब होगी 360 डिग्री पर होगी, ऐसे होगी ना. तो when delta phi is equal to either 0 डिग्री और 360 या फिर 4 मतलब 3 180 इंटू 4 कितना हो जाएगा 520 डिग्री. इन सब डिग्रीज पे क्या होगी डेल्टा पाई की वैल्यू क्या है. अगर हम इन सारे वैल्यूज को इसमें पुट करेंगे तो कॉस की वैल्यू क्या आएगी 1 आएगी, है कि नहीं. तो ध्यान से देखो, तो डेल्टा फाई 0 360 का मतलब क्या हुआ कि बेसिकली these are some numbers of pi which are some integers of pi, but these are which kind of integers, even integer, है कि नहीं. Are you able to get me or not? Now, you know that we can't only restrict us to 0 degree or something like that, because you see that whenever a wave is approaching a particle, it travels so many times. It has 0 degree, 2 pi degree, 360. It can coincide at any point or not. So that is why the phi values can vary from any point of the total 360 degree angle or multiples of 360 degrees angle. Is that clear? अब ध्यान से देखो, तो डेल्टा फाई इज इक्वल टू 2n पाई प्रोवाइड्स अस कंस्ट्रक्टिव इंटरफेरेंस. कैसा इंटरफेरेंस प्रोवाइड करेगा? इसका मतलब क्या हुआ, डेल्टा फाई की तो वैल्यू 2 पाई बाय लैम्डा होती है इनटू डेल्टा एक्स होती है, दैट इज इक्वल टू 2n पाई. सो 2 2 कैंसिल, पाई पाई कैंसिल, दैट मींस डेल्टा एक्स इज इक्वल टू n लैम्डा. इसका मतलब कि मान लो सर ऐसा है कि अगर एक पॉइंट दिया हुआ है, मान लो ये पूरी की पूरी एक सीरीज बना देता हूं, ठीक, और यहाँ पे बीच में एक पार्टिकल है. एक बेटा वेव यहाँ से शुरुआत हुई चल के आने की, और वेव कुछ इस तरह से चल रही है. ये 1 लैम्डा हुआ, फिर ये 2 लैम्डा, ठीक है कि नहीं, है ना. और यहां से एक वेव आई, ठीक, जो कि सिर्फ 1 लैम्डा में आ रही है. कितने लैम्डास में आ रही है बेटा? 1 लैम्डा में, है ना. इस वेव को कितना चलना पड़ा? 1 लैम्डा. इसके हिसाब से लैम्डा तो अलग अलग होता है ना, लेकिन रेस्पेक्टिव लैम्डास आर स्टिल सेम. इसको कितना चलना पड़ा? 1 लैम्डा. इसको कितना चलना पड़ा? 2 लैम्डा, है कि नहीं. तो ध्यान से देखो, अगर तुमने इस 2 लैम्डा में से 1 लैम्डा को माइनस किया तो कितना आया? 1 लैम्डा आ रहा है, नहीं आ रहा? Look over here. This distribution is trying to push this particle upwards or not? And this distribution is also trying to take the particle upwards. So ये पार्टिकल क्या कर जाएगा? यहाँ पर ये इंटेंसिटी क्या कर जाएंगे? मर्ज होके क्या हो जाएंगे बेटा? मैक्सिमम क्या हो जाएंगे? Maximum. Is that clear or not? You tell me one thing. Let's suppose if I am sending this wave over here, and if I am sending this wave over here, so this wave will take the particle upwards or not? Yes. You see that how this red wave will start. Red wave will once again be like this way or not? The red wave is something like this way, isn't it? So you see that these two waves, the black wave is going to do like what? Black wave is going to also travel in the same fashion, isn't it? So you see, for this reason, there is an overlapping of these SHMs or not. This overlapping of this is happening or not? Perfect overlapping. So when these kind of perfect overlapping appears, they take the particle to its maximum intensity or not. Right now we saw that, no? When we have a perfect overlapping of a square wave and all, they are, how come they have different frequencies? Their wavelength is totally different. No, no, means we are not considering. See, this. No, no, there is no. There is. This is. Wait, Baba. Here the wavelength is different. The word frequency means something else. The word frequency means this source will oscillate many number of times. Are you able to get me? But their amplitudes can be same. Here wavelength is different. Are you able to get me or not? If your frequencies are different, then they will be drawn something like in a different way. One will be like too much sharp, है ना? Another one will be of the same nature, okay, but it will be either up or downward or not. No, that is not overlapping, na? How come it will overlap? Can you overlap two different frequencies? Means one is oscillating 5 times, another one is oscillating 10 times. How come they can overlap? You only tell me. Yeah. So here the so here who said that the number of waves in one crest or trough means that I have different frequency? Red one is having different wavelength. You listen, Baba. This one didn't have understood. Okay, here it has one wavelength. This one has a bigger wavelength from the black one. Huh. So how come they have different frequencies? Can you describe me? Okay. So they have the same frequencies. Okay. Both have same frequency basically. How? Because frequency does not depends upon. Are Baba, this omega means what? Okay, I'll tell you. Wait. Let me just stop the recording.